Good morning, ladies and gentlemen. Welcome to this interesting tutorial by Bernhardt on doing automatic number plate recognition on the Raspberry Pi, with Python, of course. Since we are recording the session, so when you want to ask a question, just grab my attention and I'll bring you the microphone. Also a reminder that the second parallel session switches over on halfway point, so you might want to consider around 11:40 also if you want to instead go to the second talk of the other parallel session. Right, over to you, Bernhardt.
Okay, what I just actually want to quickly start off with, if you actually want to code along and do the project with us, there's a Github repo where you can actually download the entire source code, and then you're welcome to code along. If you don't want to, you're welcome to sit back and just enjoy it. Okay, so let's go back to slide 1. Okay, so what I'm going to be tutorialing, or show you guys a tutorial about, is the ANPR. It's an automatic number plate recognition system, which was actually coded by Quibus here for communities. The idea behind it was basically to assist communities in recognizing, to monitor the traffic that actually comes in and out of their community areas, to assist them with, criminal activity and stuff like that. Okay, so the quick question is, why did we decide to redo the project? Because the project was initially done in C++ and a little bit of other magic to get it up and running. So the first reason why we decided to redo it is because there was a lot of people who actually asked, they want to put up something like this in their own community and get it started. Now the current running code base is a bit unmaintainable, and it's very hard to actually deploy that to new systems, and that's the reason why we actually decided to redo it in Python. Why did we decide to do it in Python? Well, firstly, it's a very rapid development language to do it in, and secondly, we actually do code in Python, so it's where our knowledge base is. Okay, now the next question is, why would you want to run a recognizing system, a number plate recognizing system on your Raspberry Pi? Well, the current system actually worked on sending all the images back to a central server and processing it there. It worked fairly well, but it's not scalable. What happened is the current system's got about 4 cameras in it, and as soon as it's actually peak hour traffic, it starts getting behind, and there's no real-time, processing happening. It builds up a log of about 30 minutes to about an hour. So we decided that it would be nice to actually put a Raspberry Pi right next to the camera to actually decide if the image should be processed or not, to reduce the load on the server. And this allows us to actually expand the array of cameras we want to use and make it a wider area. It does reduces the bandwidth that would be used on your network, and because you probably will end up using something like either the WOC or wireless connection between the stuff, you don't want to put a lot of data running through it. Okay, so just a quick overview of what the activities are that we're going to do today. First one, I'm going to show you where you can get the source code. If you want to play around with it, if you want to deploy it, you're welcome to do it. The second thing is I'm going to do a quick overview of installing OpenCV. While actually it's not a problem in most Ubuntu systems, it sometimes gets a bit hairy to install it on something like a Raspberry Pi if you want the newest source codes. Then we're going to start off by just getting actually the ANPR running from some sample images we have. Then after we actually got it up and running, we'll try to access the IP camera that's actually set up there, pointing at somebody's number plate that I took out of the parking lot. Luckily, I do know the person. And then lastly, we'll try to get it up and running on the Raspberry Pi. Okay, so like I said at the beginning, you can actually go to the Github repo. It's open source, so everyone's welcome to get it. Everyone's welcome to try and publish to it. Yes?
Yeah, could I just ask a question? What's your background and what's Quant Solutions? If you say one sentence about it.
My background is I'm a software engineer working at Quant Engineering Solutions. Got a BSc in computer science, and I'm doing my honors. And then Quant Engineering Solution is an engineering company. We mainly specialize in developing management systems, but we've done a couple of other stuff as well, like jukeboxes that are on Shabeens. We did an IP, what's that called? IPTV system. So we mainly specialize in software these days, but there has been some hardware integrations around it. Okay. Okay. So firstly, if you're not on Ubuntu, or well, not on Linux, I'm going to tell you to go to OpenCV.org to go and install it. For Windows, there's nice installers, and all the source code is there to actually install it on all other, related operating systems. For the practicality of this practical, we'll actually only use Python apt-get.install python.opencv. It's the standard 2.4.8 OpenCV that's actually been released with, which is actually in all of the current Ubuntus. It works fine. The reason you'd actually want to go, and you can't read that, so I apologize for that. I'll paste the command in the README on the repo. The reason you'd actually want to build the thing from sources is because Ubuntu's actually repos are quite slow releasing new stuff, and with the new OpenCV 3 being released, they've actually added quite a lot of new features to it. There are a bit of hairy stuff to go through to actually get it to compile. Sometimes on 14.04, stuff like GStreamer doesn't want to build, so you need to switch it off. If you're going to use Qt5 instead of Qt4, then you also need to tweak some stuff. So this isn't a build it once, get it running always. It's not a 100% solution. You might need to tweak it, but the actual command here actually seems to work quite well on my Ubuntu 14.04 and both the Raspberry Pi instances I tried it on. So yet again, you might need to add some other stuff if you actually want to use some contrib libs or stuff like that, but that command should work. So for this tutorial, I'm not going to actually show you how to do this because building it on a Pi does take quite long. So we're just going to skip over that. We're going to assume we did do it, and I'm actually only going to use the Python OpenCV command to install it. Okay. So what you will need to actually get the ANPR up and running is the following dependencies. Obviously, I'm going to assume that you've got Python 2 installed already. If you don't, that's obviously just sudo apt-get install Python, and that will work. So firstly, we'll use Python. That's just something actually, I have no idea why we use it. Artificial neural network. There we go. OpenCV we obviously use for the image processing. skimage is actually used as also another way to actually handle the arrays inside the images. Postgres is what we're going to use to actually save our data, which we actually get from the processed images. And then PsychoPG2 is actually just our package which we're going to use to talk to Postgres to retrieve and save the data. Okay. So what we're going to do is we're going to start off with example 1. Doesn't look like anyone's following it, so I'm just going to run it. There's actually a nice thing. So in the source code, there's actually a folder called examples, in which I actually put up some examples on how to run it. So what I'll quickly do is I'll just quickly show you the commands inside it, so that you can quickly see that it's just basically shows how to actually run the project or a portion of the project from some sample data. So basically, in this, we've actually got a module called ANPR, right? The I just tells it where, actually, I'm not exactly sure. Oh, image file. There we go. So where the image file is, and basically all this is going to do is it's going to run through our test data. And since you guys aren't looking at the test data, I'll quickly show you how it looks. Cameras, test data. So basically this will be the images that we're going to try to run through, and we're going to try to see if it actually does return a number plate for us. Okay. Okay. And basically, this isn't a very interactive example. It basically tells you how you probably want to end up using it. All it actually does is you input an image, and it returns a number plate for you. Now, you might notice that there's some dashes in our number plates. That is the artificial neural network telling us that it couldn't actually identify the number there. So then it just puts a placeholder in it so that you can actually go and view it and it wasn't sure what it is, so it just decided instead of giving you a wrong number, it just put a dash in so that you know it got one wrong. So you'll actually see that dataset 5 didn't get us any number plates, and I have no idea why. It looks quite clear if I go and look at the image, but for some odd reason, the neural network decided that this image isn't clear enough, which is fine. We can work around it. Okay. Yeah, sorry, that's actually the next part of the example, so he doesn't need to. Okay. That's the end. Don't want to go there. Okay. Okay, so now what happened is, like I said, the first example isn't a very interactive example. It doesn't tell you what happened in it. It doesn't show you anything. So basically, it only told you, yes, we got a result, or no, we didn't get a result, right? Now you probably want to go and see, what happened. So there's a command that we can actually add additionally to our starting at command, and that's a -d.true, and that basically puts on super debugging, and that will actually provide us with some information and some screenshots as to what happened when you try to identify it. Okay, so example 2. Okay. So for some odd reason, my screen is a bit small, so the image isn't showing completely in it. So again? Oh, is it?
Yeah, but the second you press Alt, it's to the key and exit. So you have to Alt drag and it'll be done.
Okay, let's try it again. So that's not working particularly well. Okay, let's just start it up again. Okay. Well, I'm going to quickly explain to you, if you've actually got it up and running on your own computer, this probably will look a lot better than it does on here. Firstly, it will actually show you the initial image that actually got displayed, and that will be this image right here. The second thing it will do is it will actually try to show you the points of interest on it, and that's the little blocks here. Now, in the code, there's actually settings to decide how big and how small your boxes are going to be. Now, these boxes are actually related to your camera, the type of camera you have. We actually put it, the distance it's going to be from a car that's actually going to be taken. And this basically assists the system to say, certain letters that are really big shouldn't be part of a number plate, or something that's really small shouldn't actually be taken into consideration. Now, example here would be is we've got two IP cameras here. This is a cheaper version from that one, and the resolution on this one is quite a lot lower than that one would be. So to use the same code on both of them, you'd probably have larger boxes to try and identify the same areas, and you don't want to do that. And that's one of the reasons why we try to split out the idea where you've got a central server and you actually have a Python camera app per camera so that you can actually set it up per camera depending on what camera you have. The other reason for this is you're probably never going to end up buying the same camera all the time. If you want to replace a camera later, you're probably going to end up needing to buy a different one. For some odd reason, it might be that the one's not available anymore, something like that. Okay. So after it's gotten the points of interest, and if I actually could get it to show you the number plate at the bottom down here, it would have actually had a lot of green boxes around the number plate. So the next thing then is it actually goes and takes the area with the most points of interest that matches the type of idea that a number plate would be. And here is this one. And then it actually does a type of a, I think they call it top hat over it. So it basically decides to make the areas, the edges that are really thin, tries to make it a lot thinner, and then anything that's really thick just thickens out. And that just gives us a very clear indication of what is letters and what is not letters. Okay. And then after that, it actually runs it through the neural network, and it will actually provide what it feels. Yeah. So there's some of the other, I actually took this one in particularly just to actually show, I wanted to actually show where the boxes would be as to why it didn't actually detect these. But obviously that didn't work out too well. But some of the other number plates do recognize a lot better. Okay. Okay, so back to the slideshow. Okay. So now that we've actually got the ANPR running, we'd actually like it to talk directly to our IP camera and not from some source data that I've actually given you. So I've taken the liberty of setting up an IP camera for you guys. Now the first thing you need to do is you actually need to find your IP camera. If it's a new one you get out of the box and you're not too smart, well, you don't know what the IP is or it doesn't have a static IP on it, you'd actually need to go and find it. And you can do this by using the MAC that's actually on your IP camera. So I've provided the MAC for it. And then you're obviously known to which range you plugged it in. And you can run the commands, the nmap to just do a port scan over it to find the IP camera. And then the ARP and grep one down here will actually give you a list of IPs.
Quick question, what's the password connected to Wi-Fi?
Oh, sorry. You need a password. I should have actually said that. It's ANPR demo. No, sorry. I've actually got a wireless router there for everyone to connect to it. So it's capital ANPR and demo, one word, so it's 8 letters. At least somebody's following. Okay. Do you guys want me to show you how I actually pick it up, or are you going to believe me that these commands work? I reckon you're going to believe me. Say again? Yeah, I mean, why not? Okay. So before we can actually start talking to the actual IP camera, we actually need to start up the server. The idea here is that once the image gets processed by the camera app, it's actually going to take the image and send it to the server. So if we don't start the server initially, then obviously it's going to crash when it tries to send the image to the server. So it's really simple. It's a Cherry Pie web server that we actually just set up. I can show you the code. It literally starts with python server.py. It's set up to start default on your local host on port 8080, which is the default Cherry Pie port. And yeah, so I'm quickly going to start that. ANPR demo, so one word. All capitals. Yeah, sorry. So it would be like that up there. So if you actually want to just type it in. Okay. Not working. Just give it a, yeah. Do you have any success? Okay. So luckily this is only broken then. Okay. So another thing I can quickly show you is actually once you've actually located your IP camera, you can actually, because it's an IP camera, it actually does serve up some content on its own. And now I just need to, sorry, it's 100. So you can actually go and view the streams that we are going to be using. So generally one is a still image taken. For some odd reason I don't have a plugin on my computer to handle that. 2 would be a stream, and you can actually set these streams up to actually have different resolutions, have different frame rates, and you can decide to connect to which one you actually want to. So we're actually going to use 4, and as you can see it's pointing towards a number plate sitting there in the corner. So that's just a quick way to actually realize, to see that the IP you actually found for your IP camera is the correct one. Okay. So basically I'm in my directory in the ANPR git repo server, and inside you will actually see there's a server.py, and all I'm going to do is just start it with the server.py, and if you've ever worked with Cherry Pie, you'll actually just see it starts up like a normal Cherry Pie. Okay. Okay, so once the server is up and running, we can actually start running the camera app to actually see if it works or not. So in the camera file, you actually want to set up a couple of settings. The first one you want to do is your camera location, because obviously you want to tell the camera where it is, and the data that gets stored, you want to be able to search it based on a location. So in this case, I named it PyCon ZA 2015, but in the case of a community, it would probably be corner of street this and this, or wherever the location is. You want to go and set up where the server location is, so that it actually knows where to talk to it. Easily enough, default value for that. And then you want to tell it which video stream it actually needs to connect to. So in this case, we decided video stream 4. You could use anything from video stream 1 to video stream 4, or if you've got a more expensive camera, it might have more video streams, or a less expensive one might have less. Okay, so then time to run the app. Okay, so let's just quickly go through this. You basically start the app in the camera client folder. It also starts with basically with just python main.py. And what you should be seeing in the current mode is that it will only print out the number plate. Now, currently, I've actually put the code to just pull a number plate every 15 seconds. The code used to be initially that once there's a difference between images, it would have actually produced the next image. But in this case, I don't want to go and wave my hand in front of that number plate the entire time to get you guys a new shot every time. So it's just going to pull in every 15 seconds. Then all images that are checked, and this is only for the tutorial purposes, gets put into images unprocessed. So that's for you to just go and see, okay, well, something is getting pulled from the IP camera. It's a method for debugging at the current point in the tutorial. Okay, so let's quickly run it, the code. Okay, so I'm in my directory, camera clients, and I'm just going to do main.py. And as you'll see, actually at the bottom, it just said, literally just returned for me the number plate I found is TMM, and it actually didn't find the one. So it went TMM-37GP, and if we look at the number plate, it missed the one. So, okay. No, that already happened, so we want to check the next one. Okay, so on the rotated image, it actually did pick it up.
Still a lot of issues with the character recognition, unfortunately. So we train the neural net by sorting by hand masses and masses of characters, then running the neural net on it and trying to find errors, because if you keep looking at 8s, they look like Bs, and if you keep looking at Bs, they look like 8s, and then you go crazy. So we trained it with, I think, about 50,000 characters, which we partially sorted by hand, then trained a neural net, then re-sorted it with a neural net after we've trained it, and then kept kind of going back and forward trying to find the errors. Yes, not a pleasant job. Not for humans.
The number plates are supposed to use a font where those characters are easily distinguishable by machine. Are you talking about the current font or the older fonts?
Agreed, it's supposed to, and if you go to Europe, they have one number plate, and there's always a little thing in the top corner, and if you go to South Africa, there are people making these things, and some of them aren't back reflective, and some of them are metal plates, and they have different fonts, and they've got these small little fonts. So they've actually got fonts that's serif instead of sans serif. You just get heaps of weird crap.
Okay, well, one thing I have noticed with the vanity number plates in South Africa is that often they're in a different color. Do you then have contrast issues? I mean, for example, in KwaZulu-Natal, I noticed that all the vanity plates were light green on a white background.
Not with that, typically because we've got a lot of back reflecting light. What we do have is during the day, Mpumalanga has a little sun and a little stripe, and that little stripe tends to connect two of the characters, and then when you do the blob detection, it detects it as one character. What I've not done here yet is previously I detected all the characters, and if there were overly large ones, I would actually go assume the size and kind of cut them out. You know, there will never be a 3 digits big character, so do a little bit of processing like that. I still need to do that. Not at this point, no.
Okay. So if you actually, am I still sound okay? Okay. So if I actually go and type in the service IP into my browser, it obviously is a web service, and then you'll actually see that the initial 3 images I did take popped up here, and you can actually go and then search for the images. Now, it's not going to work that great. Well, actually it will. The third one will obviously... Okay, apparently my search isn't working. So sorry, I broke it. Okay, the idea is that the search worked, and it did a couple of minutes ago, and then you can go and click and to view the images, and it will disappear in 5 seconds, because I didn't want to leave it there. But the idea of this is to actually have a web interface where you can actually go and search for a number plate, type it in, and then it should actually bring down a list of all the number plates that match that. In this case, because there's dashes in it, you might want to actually go and search for dashes to see if something is unclear, and obviously the idea to extend this would be so that you can actually go and correct some number plates if you want to, and if you have a neural network, you could actually use that eventually then as training data again. Okay.
You say you can search for a specific number plate, but you've got there that TMM-37.
Yeah.
If I were to search for 237, would those -37s
Not
be
at the
turned up
current
by the
moment,
search?
no.
Thank you.
Yeah. It's something I literally put up last night, and for somewhat reason it ended to break now. So no, there's a lot of opportunities to actually extend it, and the idea is to extend it at the end. It's one of the reasons why we actually tried moving it to Python, is there's a lot of more stuff you can actually do with it then. So yeah.
Yeah, just a question about your neural net. I mean, is it a one against all sort of classifier, or what sort of, how does it work?
What do you mean when you say one against?
I mean, is it like 26 separate neural nets that says it's either this letter or not?
No,
or
it's a 900 input, 30 by 30 pixels that you just flatten
Okay.
and put into 900, and then there's 36 outputs, and I train them to be 1 or 0, and I use the letter Q, or I use 1, and because Q never occurs in our, or I've not seen it in the million odd plates that's gone through my system. I've never seen the Q, so I use that as I train anything that's garbage as that. So
Okay,
the little
okay.
GP sign, and if you get the milli from the northwest one, and there's just lots of garbage in our number plate. It's just atrocious compared to first world countries.
Okay, and then in terms of training the net, have you tried like creating a lot of artificial data? So in terms of using OpenCV to like rotate you have like a 50,000 base letters now, and then you can just shift them or like flip them left to right and say that's not actually a valid letter. And
Firstly, I've lost the 50,000 base letters, so I can't train anymore, which is sad. But I still have the neural net, and I don't have the training data, the training code anymore. So I've actually lost most of this. A lot of the training happened with the previous C++ app, and we are trying to get it running again now. So it's a bit of a Frankenstein at this point, but it is just a stopgap. I'd rather want to use, there's all kinds of structure analysis tools. There are deep learning nets. There's all kinds of different tools that I'd like to try out that wasn't available 5 years ago, or wasn't easy 5 years ago. So definitely first go that route before I retrain. But yes, when I do get to that point, I will do little bits of rotation, resizing, squeezing, that kind of stuff.
okay, cool, thank you.
Just a reminder, it's almost time for the second session to start in the parallel session. So if anyone's interested, the second talk, I mean. So if anyone's interested in that.
Okay, well, is it working? Okay, now? Okay, 1, 2, 3. Okay, cool. Okay. It really doesn't sound like it's oh, there we go. Okay. So the next thing is trying to get it running on your Raspberry Pi. Well, I'm going to tell you it runs, but it's not classified. Well, it's not identifying at the moment. So we'll quickly run through it so you might be done for the next talk. Okay. So what I did is I actually installed, there's a unofficial Ubuntu 14.04 that you can install on your Raspberry Pi, but you can also use the Raspbian distribution that they actually give for you. I prefer the 14.04 because the libraries are quite similar to 14.04 I'm running on my laptop, and that just makes it easier to debug. Unfortunately, debugging on the Pi is quite slow, so you'd like to debug it or get it running somewhere else and then just deploy it. Okay. So the first thing we actually want to do is we want to install the following dependencies. It's PyFan, OpenCV, and SkyImage. We have no use for CherryPy, Postgres, any of those on it, so we're not going to install it because this will only be the client side. It will basically process the image and it just sends it back to the web server once it detects that there's actually an image in it. Okay. So for the sake of it, I am actually going to show you, quickly go into my Raspberry Pi. And let's just log out quickly. So I'm going to start it with the X server because that's the point where I actually was right before I started this tutorial to try and figure out what exactly is going on and why it's not classifying at the moment. Okay. So, and you'll see I actually did copy the Git repo onto it. What I actually did is I decided to change the variables inside here a little bit. I'm pointing it to my own PC right here. So the server is not a local server running. I decided to change the camera location to my Pi, and then it's also just using the video stream 4. Okay. And then yet again, all we do is we run it with python.main.py, and I actually enabled the D setting inside my main.py, so it should be popping up a image at the moment. So it's basically the debug mode trying to run it again, and like you can see, it actually returns that it didn't receive any number plate from it, but the number plate was actually quite clear, and that is actually the point where I'm stuck right now when I got to it. And to be honest with you, I think the next thing would be is to start changing some of the variables on the system. So, but that could be a while. So if you guys are interested to stay while I do that, you're welcome. But otherwise, that's the end of my talk. Thank you.
Questions for the speaker before he starts the debugging marathon?
Which might be a while.
What about some of the practicalities of where the camera would be in a suburb or something, and you don't want someone to steal your Raspberry Pi and your nice IP camera? What kind of real world things are you looking at there?
Well, I think what we actually did in our community where they're currently up is there's metal boxes around them because you generally want to put a little switch right next to it as well. So it's not just your IP camera that you want to put down there. You literally put a little switch there and you're going to plug your Pi in, and you want to keep those secure. And you also need to provide some power to it. So, I mean, stuff like that you want to keep in an enclosed area. And the other thing they actually do is they actually... Sorry? Just oh, okay. Anyway, the other thing you want to do is we actually put them up quite high. They're currently, I think, about 2.5 meters, in some areas up to 3 meters from the ground. So you literally need to go out with the intent to go and steal them if you want to take them. I don't know of an instance that any of them have actually been taken. Gilles? No, none of them have ever been taken.
Thanks. Maybe one other one, just in terms of like the SANRail and that. What are they doing if they miss a number? Do they have a database that they go and look up and say, well, the closest match is the known number plate with the one there? Is that how they do it, or?
Actually, I have
any
no idea. Unfortunately, I wouldn't be able to tell you that. Okay.
Other questions?
Yes.
Yeah, so what's your sort of roadmap, what you plan to do taking this forward?
Okay, so, well, I think I've got a side to it, and I think Quibus has a different side to it. So let me quickly explain my side to you. There was actually a couple of students. Well, firstly, I want to get it to work a little bit better than it currently is on Python. And then a year back, there was actually a couple of students who tried to pull facial recognition out of the cars that were in it, so they can actually match a face up to it. And while I'm not actually too sure you always want to do that, I do think that going with your number plate, you actually want to track people's faces coming into your complex, and especially me living in a sectional title area, there's only one gate going in, and there's a lot of people that tend to slip in at that. And my way forward for what I actually want to do with the project is add something like that, is where you could actually go and take a picture of somebody's face, and you can go and say, you know, yes, I know his car came in, but I also know this person was entering the complex at times like that. And for security purposes, I think something like that would be really useful. Once somebody is walking around in a complex, you don't know the person, you actually want to know, you know, how often have they been here? Are they visiting once every day for the last 2 years? Because then that's somebody that actually belongs in the complex. Or has this guy been here 5 times in the last 2 weeks, you know, scouting? And then it gives you that motive, you know, you can go and confront the person, you can ask them, you know, what are you doing here? And usually they tend to slip up if they have ulterior motives. They'll actually slip up and say, well, no, I've been here for the last 2 years, no, everyone knows me. And then you can go and you say, but, you know, you've only been here 4 times in the last 2 weeks. And that just assists you in security purposes. It also assists you with, if there is a crime, you can actually go and check around the area, who was coming in, who is unknown. I know Kubis and them do that for the number plates with the cars, so it does assist with that. I know it's the number plate recognition system has assisted with arrests. So from my personal point of view, I'd like to see it extend far beyond the point of just number plate recognition. But yeah, that's my personal one, and then I reckon Quibus will tell you what his is.
Okay, depending on whether we're talking technical or what we want to do with it, what I'd like to see happen is all the neighborhoods surrounding us use this and share their whitelists with all the other neighborhoods. So when a car comes into our area and we stop it because it's suspect, we can say, where are you from? And this guy would, if he lives anywhere in, say, a 40-kilometer radius, hopefully it'll show up that he's a regular, and we would hopefully be able to classify him on a whitelist and be able to say, we know this guy is a resident somewhere, we know he's always in this area, and thus there is reason to trust him more so than someone that is coming into the area for the first time. The second thing would be to check a story, because the criminals tend to be pathological liars, very, very good at making you feel like you shouldn't be bothering them. And the irony of it is the guy that has all the self-confidence and projects this, he gets left alone. And the poor guy he just looks the part, he gets hassled every single time. And we want to get to that point where we're not hassling the innocent guy, the guy that we've stopped 14 times because he's got an old car. The poor guy's, he's poor, and now we're stopping him and we're hassling him, and it wastes our time, it wastes his time, and we'd like to get that better. The other thing we did, this actually, we've had a case where we could narrow down the number plates. There was a break-in. We didn't know the exact time, but we had it down to about an hour, and we drew a report on which of those number plates have not been in the neighborhood more than 10 times. We had a short list of 7. We gave it to the police, and they said, there's a false number plate. We got the image, and we actually got a face through the window, and we showed it to one of the gardeners in the area, and he said, yeah, that guy was there, and he could corroborate it, and that helped a lot to quicken the process.
Cool. Yeah, 'cause, I think it's quite an exciting project. I mean, something I've wanted to build myself with my Pi, so I'm glad Jas cool that Jas got it started. I mean, just some ideas from my side. I mean, I know I live in Cape Town, and some of the suburbs, like Rondebosch has a community district, and some in the southern suburbs as well, that run these systems where they've got a couple of access points to the suburbs, and they track the cars coming in. I don't know what they use, if they're like commercial software. Because in my neighborhood, we discussed putting something in, but it was quite expensive. So having this open source solution would be great. Just in terms of getting it out there. So have you spoken to Greg from Code for South Africa, for example? Because I mean, it seems like something that they could maybe like take an interest in. It's a sort of improvement for countrywide.
That's a very good idea. No, I've really been trying to get it out, and one of the big things with the C++ app is it was compiled against Ubuntu 10 or something, and it used a bunch of manually compiled libraries, and I couldn't actually easily replicate it for other people. So I said, yeah, just compile this code. And they would go, you do it. And I go, I'm busy, leave me alone. And then nothing happens. So I want to get to a place where it's Pi, and I tell them, download 14.04 or 16.04 Ubuntu, download this, apt-get that, drop the script in there, double-click it, boom. So that's where we want to get, or to be able to sell them a Pi, pre-programmed and everything, and they go plug it in, and they just tell us the IP of the camera, and we give it to them, they plug it into the camera, and boom, it just works. So yeah, but definitely working with people like that would be great, because we tend to be quite busy and not have any time to work on this. As you can see, it's pretty, we've rushed through it because we don't get time to spend on it because it doesn't pay.
Sure, no, same. That's why I haven't ever written it, even though I've thought about it a lot. But so just one recommendation from some other open source project that I've been involved in is really like spending a lot of time on documentation up front. Pays off if you actually want to get a lot of people involved. I mean, I see on the GitHub repo you've got a README, which is great. But like, yeah, like if you get some Sphinx docs up or put them on Read the Docs or something, then that really people might hear about it from, let's say, Code for SA, kind of get some sort of media attention out, and then like they come there and they're like, okay, well, what do I do now? And then they sort of bounce off. Whereas if you have good docs, then people can actually pick it up and contribute.
Yeah, that's a good idea. I've not cleaned up the code much, but I've tried putting in some comments about why I'm doing what, and there's still quite a chunk of work, probably a couple of days worth of work I need to do, but yeah.
Are there any other questions?
In your test you showed us here, it looks like it recognizes the number very quickly. But what I would like to ask is it quick enough that you can pick up every frame, or do you have to skip frames?
Okay, well, regarding that, it probably wouldn't pick up every frame, because what we actually do is, and I actually commented it out of this piece of code, is what we do is we take a frame and we only, after the processing is done, we'll take a next frame. So we don't stream it continuously. Unfortunately, with the Raspberry Pi, even if you get it to a really optimal point, its processing is slower than it would be on a normal computer, and to pull 30 frames a second just isn't realistic to actually process it. So yes, I think in a congested area with people driving really fast, you might miss a number plate or two. But then again, I don't know, Sunrail seems to have a lot of money, so their system might be better.
Yeah, I mean, for a different thing, I was playing around just with some image processing on my Raspberry Pi, just pulling pictures at home. I just wanted to record what was happening in the house. And I found the bottleneck was actually just pulling the images from my webcam from the Raspberry Pi. That couldn't handle very many frames at all. It was doing no post-processing at all, just pulling pictures and trying to save them to a network drive. Yeah, I couldn't get much more than like 1 a second or...
regarding that depends on the encoding of the camera, the webcam itself. I've actually found that some Logitechs do the compression or the encoding itself to MJPEG on the camera with a chip, and then you can literally get 25 frames a second from your webcam. But your standard cheap ones, I think they do SVG, I think is it. And then the Raspberry Pi actually needs to go and convert it to MJPEG, and then you get what you said,
Casey,
about 1 frame.
We won't be able to do this on a Raspberry Pi 1, but we are hoping for a Pi 2. We are seeing it, I'm not sure whether it's around a second. I think we're trying to get it down to a second, and then on 4 cores we should be able to do hopefully 2, 3, maybe 4 frames a second. If we can get to 2 frames a second, you can get more or less all the cars.
But I mean, I think the neural net classification will be almost instantaneous, right? I mean, a net is expensive to train, but then once you've got trained, like to actually process it is fast. So.
Just quickly, are there any legal aspects to this? Thinking like right to privacy.
Yes, there are.
Seems to come up a lot.
It's a difficult one. We as a neighborhood have got the right to close down, and we have boards up front that says we are recording you, and whatever you do here, you're on camera, smile, and that kind of covers us. On the other hand, if you are in public, anybody can stand next to the road and write down the number plates. So why would it bother you if a machine does it? But on the other hand, the machine does it very well. But and but anybody can do that. So the fact is, if you think, I think you do have legally, there might be some level of privacy requirements. I'm not sure what the legal framework is. If you think in terms of natural rights, the second you go into public, someone can see you. Someone can write it down. We could just pay guards to write it all down next to the road, or we can have a system that does it for us. So at that point, I'm not sure, but the way we use it, I think that's more, for me, that's how you use that data is more of the issue, not as much having the data as what you do with it.
You only really know when the first guy takes you to court? Probably. Sorry.
I was also wondering, just very quickly, have you tried? Has WDR been useful at all with the cameras for this thing?
Wide dynamic range on the
Yeah,
cameras?
yeah.
No. The wide dynamic range gives you a lot of background. It basically is a short, quick image, a short shutter speed, and then a longer shutter speed, and then you just combine the two. So what that does is it gives you the fast-moving stuff quite crisp, and what we don't care about the sidewalk. So it can be black. I don't care about when it's night. I just want to see the number plate. I don't care about the car. So I just set it short.
It could be useful in the case where you want to see the contents of the car, i.e. the people.
Ironically, the way we've solved this is not trying to do it with one camera, but just have a second camera that's set in a mode that gets a lot of light, that has got a slow shutter speed, and it's blurry, but you actually get, even at night, we get color on those things. So I can get the car's color, but I've got to check a second camera, but that's fine.
Yeah.
Okay.
I was just thinking in terms of the whitelist. I mean, that should also be quite cheap to run, right? Like I'm just having like a little table of like whatever 50 million number plates top doesn't take much data, and you can have whitelist, blacklist, and if you report, you know, if my car gets stolen, I report it as stolen. All these, like, more and more people are running these systems. Suddenly, you pick it up. Hang on, that just entered somewhere over there.
We actually have a guy that here in Joburg that has an API that we can get access into the Unicode database. That is the police's stolen car list.
Okay.
That is one of the other things that prompted me to get this thing up and running again, because what I have now, it would be very hard to interface with it. And that is attractive because now you're preemptively stopping it. What we're doing now is we are more using it as a tool for some a priori, and we're using it not a lot. Actually, we don't have crime anymore. Sure. So to be honest, we're not using it. It's sometimes off for a month, and then I go, oh, the machine's down, switch it back on again. So we're really lucky. So the privacy questions, it doesn't come up because we don't use it. And we only use it when there's a criminal case, and we only use it when it really affects someone. We've had people come in and say, oh, someone swore at me. I don't live in this area, but I see you've got a camera. Can you help me? And then we just go, make a police case, bring the case number, and we'll help you. And then they don't. So we don't help anybody.
Questions in the back here?
Just anybody.
That actually answered a lot of what I was going to ask, which is, what is the point of doing this? How useful is it to know what number plates go in and out of your neighborhood? It's not like anyone cares.
For the most part, it's the a priori. So
Yeah.
we get to stop someone. And now you've got this guy. For some reason, you've looked at this guy and you've classified him as being suspicious. So he might be poor, he might be different racial background, and now you don't want to discriminate just because this guy falls into this massive group. You want more reason, because he looks suspicious, he acts suspicious, but he might just be a resident, and he says he's a resident. Now you can say, okay, take me to your house. That's an unpleasant thing to do. Now you're walking behind it, and we've done this, and it's not fun for me. I don't like doing that. It's not fun to force someone to take you to his house, unlock the door, and then you go, okay, well, yeah, clearly you live here. When you can check that electronically, then you can go, oh, yeah, sorry, and be aware, we've had a little bit of crime, and then you turn it from a unpleasant encounter into a pleasant, I don't know you yet. Join the neighborhood watch. And the whole thing turns around and becomes a nice thing rather than an unpleasant thing.
That makes some sense.
Are there any other questions?
You haven't thought of taking it further and commercializing it?
No.
Why not?
Because it doesn't work well. It works good enough for us. I don't mind if I miss 1 in 2 plates or 1 in 3 plates or 2 out of the 3 plates. Number plates keep passing by all day, and at some point I'll log you. So I don't really care exactly how accurate it is. If there's a number plate error in it, I'm not going to bill you for it. I'm not going to stop you. If I search for your number plate and I don't find you, I'm not going to arrest you. It's just a little bit of a priori.
Follow up on that. Sorry, I hear what you're saying, and from what I understand, you're saying that in your environment it's not working well enough yet to take commercially. Is that right?
Yes, yeah, something along those lines. So we've done tests on the old system. The new system's not there yet.
Yeah.
On the old system, with certain cameras and certain times of day, we get 90% of the cars passing by, 9 out of the 10, even 19 out of 20, so 95%. Other times a day, we get 1 out of 10, dusk and dawn. It tends to be very difficult because the sun's really a pain in the arse. And then some of the other cameras, we get 80% of the cars coming by, and that's good enough for us. Sometimes what we see is we'll get 95 or 90%. We'll see the number plate, but we'll see a couple of false positives as well. And for a commercial system, that's going to be a hassle. And then I've got a lot of other commercial stuff to work on, and this is not my core business.
That's fine. But can you imagine for a bit that you had to go into business with a company such as ADT, just countrywide, and you could develop the system far enough to be accurate enough to be able to build a countrywide list of numbers, and you had a break-in in a certain area between a certain, or at a given time, at wee hours of the morning, and you could start tracking and helping fight crime through this kind of method.
Yes, that is the dream. However, I don't like companies like ADT because they are big and dumb and stupid. We've had cases where we actually caught the ADT guards stealing from in our neighborhood. A couple of cases we were personally, our business were burgled by them. Someone else came there. He came there and then pretended to not see them, and then one of our neighbors caught it on camera. Any case, I don't like the big companies. I like the small companies. I like the neighborhood owning it because then people think about it. I like personal responsibility above checkbook security. Once you make it your own, once you are involved, once you think about it, you think about privacy, you think about those things. When some pleb is paid 2,000 Rand a month to monitor the system, he is going to give access to anybody who comes along with 500 Rand. I don't like that.
Also, I would say the biggest concern with taking it nationwide is the potential for abuse, because now you've got this centralized database tracking everybody. I mean, we've just seen the huge info bomb of the adultery database that was dumped out there, you know. Now, if we're tracking number plates and we see, okay, my husband's number plate is always visiting this particular person, and I don't know why he's going there, kind of thing. I think doing it locally, community-wise, makes sense. Communities know their own community, knows what works, knows what doesn't.
I like communities sharing among each other, but the communities owning the data. I prefer that method because there's no central point. You can steal all of it. You'll have to hack hundreds of different systems, and it'll be a lot harder to integrate, but it would be, I think, more robust. And then, yes, well, the data thing, that's always a risk, but... Yeah, the problem, for instance, when people say privacy, then, yeah, 2 people were murdered in my neighborhood. An 80-year-old man were beaten to death with a hammer. That's not a pleasant thing. That's not something I want to think about. A girl was gang raped. That was 8 years ago, 7 years ago. Since then, we've had a massive effort. We've arrested 70 people. The community have arrested about 70 people. We've closed down. We fought a high court case against our local government and won it. It is to close down. It's just everything has been stacked against the community, and then people go, yeah, there's this one law, and you're not allowed to do this and that to save yourself. So I'm with you on that. But on the other hand, you've got to look further ahead and the possibility of abuse. So both points are valid.
One question quickly from my side. Typically, this is all around the visual side of recognizing a car, getting the color. Have you tried doing any audio fingerprinting as well? Like, if a car comes past, just record its sound for the 3 seconds that it's passing you. And then if you later have 2 VW TDIs or something, you can see that one maybe makes a more specific sound, and that's the one you're looking after.
I've not thought of that. The cameras do have audio sensors, or at least you can plug in, and some of them actually do have it. So that might actually be something to do to help identify the car type, because the classification of the cars are not very good. There's not very nice algorithms for that. To determine color is not really easy. It's actually surprisingly hard. And yeah, so there's a lot of things that can be done. I'd love to do facial classification, again, do a whitelist of known people, that kind of thing. But someone has to do it, and no one else is volunteering, and thus it's not happening because I'm busy and everybody's busy and nobody cares. And one of the bonuses of my areas, we have virtually no crime. We had a break-in last year, and we had one the year before that, and we had one car break-in this year. That's in... What? Right next to the CSIR, between the CSR and the N4. But all the areas there have very active neighborhood watches. We've worked with the police. We have help teams with bulletproof vests, and we are aggressive. We've lobbied the police and bribed them to do their work. You take them cake, you feed them, and then they get to know you. And you realize the police aren't bad. They just don't care. And if you give them a reason to care about you, they actually care about you. It's just laziness. It's not necessarily evil. It's just people just don't care.
Are there any other questions, provocative or not? Is the system working a little bit now, or not?
I don't know. Quickly.
We've got an image up, I see.
Yeah, quickly press space and...
Nope.
Nope, there's still something broken. Okay. The fact that it's not getting anything, I think, is probably a package throwing an exception, and I'm doing a bit of trying to suppress exceptions, so we're not really seeing when things go wrong. So
Well, I don't know, I see something here. Yeah, I see something.
yeah, it's definitely finding the characters. So it really ought to be fine. Oh, there it is. TMM 137GP. Yeah, it did. It just probably timed out or something. Okay, cool.
Well,
It's
I did
working.
find
Yay.
something. And then it crashed.
Yeah, one quick thing that's related to this. I noticed when I was playing around with OpenALPR, I noticed that if I tried to take the license plate off, when I gave a talk about also a Raspberry Pi thing a while ago, I tried initially to do the same thing with you, put a camera on a license plate, and it never picked up the license plates. So what it actually looks for, it has to be attached to a car, and only then it actually picks it up. So yes, I don't know if what they might, I don't know what they're doing there. Do you know if it's something useful that they're doing there that might be useful for you, or what?
I'm not sure what they do. Unfortunately, I'm not. They do have the same basic steps, localization. I think they use the gradient technique to try and find the area, and then from there they do the rotation with U-lines and trying to find the corners. So I'm not exactly sure. I do know they have a couple of steps, and they reprocess areas, so they're then a lot more thorough than my system is.
Yeah, so even though I used the actual license plate, it couldn't pick it up. But if I took a picture from an old magazine, ripped it out, and put it there, then it picked it up just fine. So
with license plates, it's one of those things that it's area specific, it's license plate specific. It's a very specific thing. You will never make one that'll work for all the license plates in the world. You'll have to always customize it. So you have to write the thing to be customizable, to be tunable. And that's just one of those things that will always be the case. Yeah, it is.
Doesn't it help the fact that all license plates have the solid color border around them with contrast?
They don't always have that.
Oh, okay. They're supposed to, by the way.
Yeah, they're supposed to. What you often see, we've got a couple of cars in our neighborhood that don't have that, and it's a white car with a white number plate that just ends. So you have these letters, and there's just no end to it. It's just a big white canvas with letters in the middle.
Difficult. Any other questions, comments, suggestions? Well, thank you. We were asked to end a bit early in order to avoid the crush at lunchtime. But anyway, I'd like to thank the speaker and, well, the speakers, I should say, since a lot of questions are. Oh, yeah.
Yeah. Yeah, okay, so that's done.